Good morning all. Today I am going to handle about security for GSM. So usually a GSM is on air interface where while transmitting through air medium, the GSM utilized to encrypt the data using of like IMSI. So usually for this process, the SIM card subscriber interface module is provided with 4 to 8 digit pin to validate the ownership of the SIM. So for this entire end-to-end process, so three security algorithms are utilized by the GSM. The first one is A3, and second one is A5, and the third one is A8. So A3 algorithm used for authentication of the user, and A5 algorithm is used to encrypt the data two-way, right? Like from the handset to the infrastructure, and from the infrastructure to the equipment, mobile equipment or handset. So A8 algorithm is used for generation of the key. So like that wise we have three algorithms for the security in GSM. We will see what is the role of three algorithms specifically used for secure transmission of the data between authentication and encryption scheme. So here we have mobile station, radio link and GSM operator. So as I said in the previous slide, so there are three algorithms A3, A8 and A5. So where A3 and A8 algorithm will be embedded in the SIM subscriber interface module where we used to slot the SIM in the mobile phone. And this GSM operator will have the same set of three algorithms, that is A3, A8 and A5. So initially between the GSM operator and the mobile station, the random value will be shared. So this random value, with the help of this random value and the key ki, so the A3 algorithm will generate the signed response. So similar to that, right? So from the random and the key ki, the SERS, that is the signed response, will be generated by the A3 algorithm at mobile station, that is inside the SIM card. Parallelly, in the A3 algorithm, which is located in the GSM operator, with the help of same key. So this ki and this ki should be same. So this with the help of this ki scheme, ki key and the random number, so the same SCRS will be generated. This signed response, how it should be? It should be same between the mobile station and the GSM operator. So this particular SCRS will be given to the A8 algorithm. So parallelly here in the mobile station also, in the A8 algorithm, the same SCRS will be given, but the key for both A3 and A8 should be same, right? So here it should be same. So once the authentication, so as I said, once both the SCRS are equal, then that value will be given to the A8 algorithm, as I said. So upon getting the SCRS and the KI, the A8 algorithm will generate the key KC, and with the help of function KFN, and here also similarly, so this key KC will be generated with the help of function which is given to FN is given to A5 algorithm. So where this A5 algorithm is used to encrypt the data with the help of the key generated by the A8 and the FN. So the message will be given MI. Based on the message, it will be XORing, and then the data will be sent as an encrypted data to the GSM operator via the radio link. So similarly, from the GSM operator also it does the same operation. It will encrypt the data and send to the mobile station. So once the encrypted data is received from the mobile station, so the A5 algorithm will also reverse the process for decryption. So it will decrypt and give the message, and here also it will decrypt and give the message with the help of A5 algorithm. So this is the entire process of authentication and encryption scheme. So in the authentication, if you go for the GSM architecture, in the authentication, the main responsibility module for authentication is AUC. So authentication center, which provides the parameters for authentication and encryption. So that is what I said in the previous slide. RAND, CRS and KC will be provided by the authentication center. And the HLR, home location register, it provides the MSCs with triples of these three numbers. So that is like three values, same as CID, and handles the mobile station's location. So actually we have briefly discussed about the MSCs and HLR and the AOC while we are discussing the GSM architecture. And the VLR, what the VLR will do is it will store the location of the visitors, right? So when the visitors moves away from the home location, the VLR will be updating all the details about the visitors, all the of the subscribers to the VLR. So that we have just already seen before. So let us see about what A3 algorithm will look like. So the authentication algorithm is what A3. The main goal is that to generate the signed response, right, to MSC with the help of random number RAND. So the input we are given to the A3 is what random, and we are generating an KI key which is about 128 bits. Then it will generate 32-bit random. The A8 algorithm its main role is to generate the key. So it generates the key KS, right? The input given to this particular A8 is SRES, that is what a signed response, and then key KI with 128 bit, and it generates the key KC, so which is used by the A5 algorithm for encryption process and decryption as well. So one of the logical implementation with A3 and A8 is that, as I said before, A3 and A8 algorithm are embedded in the SIM subscriber information module, SIM card, and then the operator can decide which algorithm to be used. So there is an option directly you can use to generate the key, or you can use the A3 plus A8 to generate the key. So this algorithm is independent, implementation is independent to the hardware manufacturers. Most of these A3 and A8 algorithm are completely closed. It is not open source. So here the A3 and A8 algorithm. So both of these algorithm, mostly all the GSMs will be having this one, as I said before. So COMP 128 is used as an integrated module, so where we will be given a random and KI. With the help of this one, the KC is generated as a package. That is what. So before we saw it a single individually A3 and A8 in the couple of slides back, but inside the sim you have an COMP 128 module, so which is consist of both A3 and A8 algorithm, so which is directly generates the key case. So A5 algorithm, as I said, so this is used for ciphering and deciphering it. So with the help of key KC, so it is implementation very efficiently on the hardware. The design was never made public. So it is leaked by Ross Anderson and Bruce Skinner. So the variants of this A5 algorithm, it is A5 bar 1, it is pretty strong, and bar 2 is weak version, and bar 3 is what GSM Associate Security Group with 3GGB design, and it is based on CASME algorithms, which is used for 3G mobile. And this is the logical process how this A5 implementation works. As we know that from the mobile station, with the help of this A8 algorithm, we will get what? We will get this KC, and then the function KFN is the 22-bit, which is generated by the A5 module itself. Means It is given to the input by the SIM card to the A5 module, and then it will generate 114-bit key, which this key is used to XOR the data. So the data is 114 bit. So once the data with this 14 bit generated by the A5 is XORed, and then this 114 bit cipher will be generated and sent to the BTS base station. So where the similarly 22 bit F1 will be generated, and the KC with the 64 bit is generated by the A8 algorithm, which is located in the BTS, and with the help of this A8, 114 bit will be generated. So this 114 bit and this 114 bit should be same, then only it can decipher, that means decrypt the data which is sent by the mobile station. So once it is decrypted, the data will be the original data will be sent to the further process by the BTS. So this is the overall picture how this A5 algorithm works with the VLR, HLR, EAR. So here you can see the mobile stations where you have multiple mobiles. So we are directly connect to the BTS, where all these process which we have discussed in previous slides is happening around here. So this is the transmission module, and here you have the SIM, and here you have the A3, A5 and A8 algorithm running on it. So between this particular communication, the data is ciphered and sent to the BTS, from the BTS to the BACs, and from the BAC to the MSC. So here it has the network management and base station subsystem, and once this data reaches the MSC, based on the availability and based on the user, the VLR, HLR, EIR, and all these process will be happened as we have seen in the GSM architecture. So with this note, so I will be we are winding up this particular session. So thank you for your patience. We will look forward upcoming topics in other video lectures. Thank you. Have a great day.